welcome to our second video on calculus 001. Today we are going to be proceeding with our study of calculus. We would briefly look at a concept called the second derivative, then then see if we can still push it a little bit further. I'm hoping that the video wouldn't be too long because I don't want to bore you with um, stuff. But then let's just see how it goes. So we have been working all along on. Okay, maybe let me check. Okay. Okay. Uh, we have done derivative of functions with quotients. Okay, and technically, okay, before we go to, let's look at some trig functions. Let's look at some eventful trig functions. Okay, I think I have a good idea of what we're going to do today. We'll look at some very beautiful trig functions, how to do the derivatives. Then we'll look at the second derivative, further higher derivatives. So I think we can just launch straight at a question, uh, something like hmm, what happens if we attempt to find the derivative of tan theta? Let's suppose, okay, this MTH 002 JPEG. So we want to look at differentiation of some trig functions. Of some trigonometric functions. Okay, so um, let's look at sine theta, for instance. But before we do that, let's have a recap. We know that if recap, if y equals cos x, if y equals cos x, then the y dx will be what? Minus sine x. And this is 1, 2. If y equals sine x, then the y dx will be cos x. We already know that, but I just said we should mention it again because we are going to need it further. And if you remember when we started talking about trig, we talked about tan, we talked about cot, talk about cosec and all those ones. So let's see what we get when we do the derivatives of these ones. Now let's look at tan theta. Suppose that y equals tan theta tan x. Okay, then what is the y the x going to be? Okay, will be what? Okay, solution. The solution will be like will be like this. We know that tan x is the same thing as sine x over cos x. We have done that before. So if we say dy dx, when x is tan x, when y is tan x, then we know we're doing the same thing as d dx of sine x over cos x. That's what we are technically doing. So what are we going to use? Apparently, we are going to use the what's it called now? The quotient rule, because this is a quotient. So we shall be using the quotient rule. Okay, now let's save the page and move on to the quotient rule. Okay, the quotient rule for this particular situation. All right, so we know that, like I said, so we are looking at d dx of actually what I wrote last, the y dx I wrote last was wrong, but then just pardon me. That's sine x over cos x is now going to be, okay, like we normally do. You hold the bottom constant at the top, that's cos x, then d sine x minus sine x d cos x, everything over cos squared x. This is going to give us what? We know that if we take the derivative of sine theta, if we take the derivative of sine x, it gives us cos x. So this is going to be cos x dot cos x minus sine x. So when you take the derivative of a cos x, it gives you minus sine x. That we have done before. This is going to be cos square x. Now, this becomes, when you take the product of cos x and cos x, we have cos squared x. Now, when you take this minus sine x times minus sine x, that becomes plus sine x and everything over cos squared x. Now, sine squared x plus cos squared x, that's 1. So this is going to be 1 over cos squared x. Now, this is the same thing as 1 over cos x times 1 over cos x. Now, 1 over cos x, we know from previous discussion as a sec, all right? This is now going to be sec x dot sec x, which is going to be sec squared x. All right, that is what the answer is going to be. So, in other words, d dx of tan x is sec x, which I think is delightful. I think that is really delightful. Let's look at the second one. What if the situation is reversed? What if the situation is reversed and we're asked to find the dy, the x, like, okay, example 2 now. Okay, let's make it, let's have some fun. Let's do some bright colors. Okay, so the y, the x, when y is cot x. What is cot x again? That's a um, cosine cos x over sine x. Now cot x equals cosine of x over sine of x. All right. So let's work out a solution here. So we are now looking at the x of cot x, which is going to give us the same thing as the x of cos x over sine x. Now, I may sound like I'm moving too fast, but then you have the liberty of slowing down your video, or reverting, pulling it back. And that's the beautiful thing about having this, I mean, about this technique. So this, of course, we know we are going to engage the quotient rule again because of the nature of what we have here. So it's going to be sine x d cos x minus cos x d sine x, everything over sine x squared. That's what we are going to have. So let me save this page again and prepare us for another page. Okay, now this is okay. So we are going to have like a if I repeat what I had, I have to repeat it. So d dx of cos x over sine x is going to give us I think it's going to give us sine x d cos x minus cos x d sine x, everything over sine squared x. Okay, so now this is going to give us sine x. What's when you take the derivative of cos x, you get minus sine x minus cos x. When you take the derivative of sine x, you get cos x, everything over sine squared x. So when we have this situation, we can say this is going to be minus sine squared x, and this is also minus cos squared x. Now everything over sine squared x. Now this, what we have at the top, we can factor out minus 1. So we have minus 1 here, and then we have sine squared x plus cos squared x, everything over sine squared x. All right, so this is going to be, this is, of course, this is 1. All right, this is 1. And okay, I'm just being playful, don't mind me. Uh, this is 1. So move on to the next page, and we say this is going to be, therefore, d dx of cot x is definitely going to give you something like minus 1 into 1 over sine squared x, which is going to be minus 1 over sine squared x. So this is the same thing as 1 over sine x dot 1 over sine x, which is going to give you cosec, but it's negative. If, okay, yeah, negative, but this one won't pick a negative sign so that we don't cancel out the negatives. So this is going to be negative cosec cosec squared x. So that's going to be your answer. Okay, which I think is cool. Um, let me see what next we can work on. Okay, let's look at something else. This is good. I'll do one, then leave the other one as an assignment for you. All right, so that you would not like an assignment per se, maybe like an exercise for you. So I'll pick one. Now the second one shouldn't be much of a big deal. Just follow the technique that we have been using so far. The other thing we have here is that we want to find we say let y be sec x. Find dy dx. Now solution. The solution to this is going to be like this. Let's use a more a more sprightly, a less wintry color. Okay, so we have our what is sec x? So we know that sec x is actually 1 over uh, cosine cos x. All right, so So we can now say d dx sec x is actually the same thing as finding d dx of 1 over cos x. So it's the um, uh, we see a quotient problem, so it's a quotient rule. So we know that d dx 1 over cos x is definitely going to give us cos x d dx1 minus 1 d cos x. Okay, everything over cos squared x. Okay, so this is going to give you cos x. When you differentiate a constant, you get 0 minus 1. When you differentiate cos x, you get minus sine x. Okay, you get minus sine x. Okay, yeah, and then the bottom is cos squared x. So this is going to give you well, that's going to be 0 minus 1 times minus sine x over cos squared x, which is going to give you sine x over cos squared x. What is sine x over cos squared x going to give us? This is going to give us the same thing as 1 over cos x times sine x over cos x. I hope you understand that. We split this into 2 to give us this denominator, and this one remain as they are. So this is going to give us this on its own is sec x, and this on its own is tan x, sec x tan x. So that's our final answer for that. All right. So for your for your take home, for your take home, for your take home, let us see what you will come up with if you find the derivative. Um, find the y dx when y equals when y is 1. Cosec x 2, um, sec x cosec x 3, sec x sec x over tan x. Okay, now this I just changed my mind. This is going to be group assignments. All right, which will be submitted when next we see each other by God's grace. Tuesday 2nd, by God's grace, we should meet again. Okay, now having done that, we can now move on to sorry, we can now move on to what I have for today initially, which is a second derivative, second and higher derivatives. Okay, second and higher derivatives. Uh, I want to go. Okay, let's go grayish. Mhm. Now, so we know that when you have a function, when y equals f of x, that's an ordinary function. Then we can say y prime, that's the first derivative of y, that is d dx of f of x. So this gives you another function, which you can still differentiate again. As long as you have a function, you can differentiate it. So if you differentiate it again, this prime becomes y prime prime, which means that so you are differentiating the whole of this bunch again. So you are now having something again as a d dx of d over dx of f of x. Okay, that's cool, isn't it? So this is going to be you let's look at what you have beneath as a single object. So this is going to be d squared over the x squared of what? F of x. So this is what we call the second derivative of this is what we call the second derivative of a function. This can continue, of course. This can continue. So if you dare, you can have it again as a y33. That is the third derivative, which is going to give you well, already we have this one as second derivative, so we are differentiating it again, d dx of d squared over the x squared of what? The initial function f of x, which is going to give you d3 over dx3 of the function f of the function f of x. So you can continue like that. You can continue like that until you have whatever you desire. So when you can the general term for it is that you can have you can e- eventually have something as crazy or as insane as um dot dot dot, meaning that what we have been doing we are continuing it. So we have something like y hen raised to power n, which is going to give us d n over dx n f of x. This is the nth derivative of a function. That's the nth derivative of a function. Now, I think it is what do we need this for? Well, it all depends on how the problem is posed. It all depends on how the problem is posed, and I'm very sure that when we get to the practical aspect of the whole thing, we will see it. Let me see how long I've taken. Okay, 20 something minutes. Okay, let's see if we can push this thing to like 45 minutes because I think I'm actually enjoying it. Let's see. Let's look at an example. So we have if your function is in fact sine x, okay, show that the second derivative of that function equals minus y, while the fourth derivative of that function equals y. All right. This is cool, isn't it? This, this is really cool. This is really cool because we are saying that if you continue to manipulate a function, then you will come back to that function. Because our initial function is this, which is y, And we say that if you bash it good well enough, you are coming back to it. Okay, when you keep pushing and pushing, it comes back to you. So let's see solution. Let's look at the solution to that. Solution. Um, well, y equals sine x. So y prime, the first derivative, of course, that's going to give us cos x, isn't it? It's going to give us cos x. So now that's that is y prime equals d dy dx, which is going to give us d dx of cos, I mean, sorry, of sine x, and it's going to give us minus cos x. It's going to give us minus, okay, of course, x, right? It's going to give us minus sine x. Oh, what am I doing here? Sorry, sine x. This is sine. I'm sorry. This is sine x, so it's going to give us cos x. It's going to give us cos x straight up cos x. All right, so we will now find the second derivative. We find the second derivative, which is going to be d squared, like d squared y over dx squared of what function now? Of this function, because this is the first derivative. So we are finding, if you are finding the second derivative, it means you are finding the first derivative of this first derivative. So this is going to be of cos x, which is going to be minus sine x. Of course, sine x is y, so this is going to be minus y, which proves our first claim. All right. Now we continue to bash it. We continue to bash it. So y prime prime prime. Unfortunately, there's no way you can just jump straight at y4 without passing to y3. So this is going to give us d3 d dx of d squared over dx squared over of cos x. Now, d squared over the x squared of cos x, we have found that to be what? Minus sine x. So what we are looking for is technically d dx of minus sine x, which is going to give us, so this is negative, so it slides out because it's a constant, d dx of sine x. All right, when you take the derivative of sine x, you get cos x. So it's going to be minus cos x. So we have found, therefore, you can say y33 equals minus cos x. All right, so let's do it one last time. So y high v, that's how I normally write it, is going to give us nothing but d dx of y3, which is going to be d dx of minus cos x, which is going to give us nothing but minus d dx of cos x, which is going to be minus sine x, which is going to be sine x, which is the same thing as y, which is exactly what they told us we are going to get. So this is interesting. I think you'll find it interesting. Just look through it carefully and try to understand the principle behind it. And please enjoy it. It's something that you need to enjoy, not to endure. Okay. Um. Well, there's this one here that is complex looking. Okay, and when it's complex like that, you do it. That's that's your problem. That's actually your problem. But Okay. All right. Let me do it. Let me do it. Then I'll leave the next one to you. And there's some other. Okay. Okay. Let me do it. It's okay. It's okay. It's okay. So we have find example. I think I won't partition the board this time around, and to make you see it properly, let me pick uh, let me pick uh, blue and like navy blue. All right. So now this example, it says find find the second derivative of y, which is the same thing as f of theta, which is the same thing as sine theta over 1 plus cos theta. We are looking for the second derivative of this function. Now let's look at it. Let's launch at it. Solution. Okay. Now the variable is theta, so we are going to be saying y the theta, not the y the x, because we have changed the variable somehow. Okay, your friends just send me a snap. They're on a streak. Interesting. All right. So if you want to join me on streak, you are free. All right. Equals f prime theta f prime theta. That is the first derivative, which in this case is of course is a quotient problem. So it's going to be 1 plus cos theta d sine theta minus sine theta d 1 plus cos theta, everything over 1 plus cos theta all squared. So this is going to give us the same thing as 1 plus cos theta times cos theta minus sine theta. When you take the derivative of this, you take the derivative of 1 first, which is going to be 0, the derivative of cos theta, which is going to be minus sine theta, everything over 1 plus cos theta all squared, which is going to give us nothing but 1 plus cos squared theta and minus that's plus sine squared theta over 1 plus cos theta all squared, which is going to give you nothing but 2 over 1 plus cos theta all squared. Okay, that's the first one. Okay, okay, I think let me give me sorry, I think I've made a mistake here. When I'm done with, I didn't open this bracket. So why this was this, then I should have multiplied this one with this one as well. And this shouldn't have been, this should have been cos theta, not 1. I'm sorry. So this shouldn't be 2, this should be cos theta plus 1 in fact. Oh, interestingly, that's the same thing at the bottom. So we can cut off this one and cut off this square. And we're going to have 1 over 1 plus cos theta. That's the first derivative, ladies and gentlemen. That's the first derivative. So we save it because we need to do the second derivative now. Yeah, so d squared y d theta It's going to give us the second derivative of theta, which is going to give you the theta of 1 over 1 plus cos theta. All right, this is going to give us nothing but 1 plus cos theta d1 minus 1 into d1 plus cos theta over 1 plus cos theta all squared. Okay, this is going to give us 1 plus cos theta 0, because when you take the derivative of a constant, it gives you 0, minus 1. When you take the derivative of this, it's going to give us minus sine theta, everything over 1 plus cos theta all squared. Okay, so this one is dead because of that 0. This one is going to be plus sine theta over 1 plus cos theta raised to power 2, which I think is the final destination. So you might double check, which means that we may be true with that one for now. If you need it, you go back to it. Again, I'm going to send you these scribblings. I'm going to send you these scribblings because right now I want to attempt something which is okay. Exercise. Your exercise will come after what I want to discuss next. Okay, let's look at this. Well, maybe. Okay, now let's look at this question. I'm going to is a practical question so that you would understand. I'll feel guilty if I don't do this question for you. It's a practical question. It says, uh, example, prac. Okay, a particle moves so that the distance s a feet traveled after t6 seconds is given by distance s equals f times t. Is a function of t. It's not f times t. It's a function of t. 1. Find the expression. Find the expressions for the velocity and acceleration. Acceleration is single L. Sorry about that. Of the particle after T6 and velocity and acceleration after 1 sec. if s is actually 4t squared minus 3t, 1, 2, s is actually cos 2 pi t plus sine 2 pi t. Yes, this is a fantastic question. Okay, so solution. So I'm going to do part of it. This part of it, that's your own cup of tea. I'll do the simple one, you do the hard one. That's the usual thing. Okay, don't hate me. Okay, so now a particle moves so that the distance. So we have been given the function to be. The function now is s equals f of t. All right. So the velocity of the function is the first derivative. That's so ds over the t. That's the velocity. That's velocity. Okay, which is the same thing as f prime t. And the acceleration. And the acceleration is when you take the second derivative, acceleration. Acceleration is going to be equal to d squared s over dt squared, which is going to be f prime dt. So that's the first part. That's the first part. Now the second part is this area. They say that we should look for the velocity and acceleration of the particle after t seconds. Okay, that's the part we have done now. Okay, now and the velocity, that's this is the second part now. Now the velocity and acceleration after 1 second, if this is the function and if this is the function. So those are two different problems. So I'm going to solve the first one by, looking for the acceleration after 1 second. And you are going to solve the second one by looking for the acceleration after 1 second. Okay. All right. So the function we are dealing with now is a function. The function we are dealing with is number 2. The function we are dealing with is x equals 4t squared minus 3t. All right. Um, so let's call it s prime now. It's going to be what? D ds dt, which is going to be the derivative of this guy, which is going to be 8t minus 3. So that's going to be the formula. All right. So at t equals 1, then the s prime, that is the velocity. So this is the velocity. So f prime is going to give us nothing but 8 into 1 minus 3, which is going to be 5 feet per second, since we have been given the what have you before. Now the acceleration, that will be the second derivative, which is going to be the square s over the t squared, which is going to be d ds of this item, which is ds dt, ds over dt, which is going to be d ds of what's that guy? 8t minus 3, which is going to give us nothing but 8. Okay, so it's nothing but 8. So what's going to be the acceleration? The acceleration is going to be 8. We have nothing to accelerate because the second derivative has not yielded any. Uh, the acceleration is going to be constant at 8 feet per second because there is no variable for us to get any. So it's going to be moving at constant acceleration at that point. So there's nothing we need to do about that again. All right. So I hope you enjoy this session. If you do, or if you don't, you will still do my assignments. So um, group assignments. I prefer the group assignments. Your group assignments is this. First, turn the vids into physical notes. 2, turn the video into physical notes. 2, um, if mm, if y equals tan theta, show that the square y over the y squared equals 2y into 1 plus y squared, where of course y equals tan theta. Okay, do that. That's one. That's one. 2. Oh, actually, sorry, that should be 3. Differentiates with respect to s. Okay, find d square y of and dx squared. Okay, if y equals cos squared x, 2, y equals cos x over 1 minus sine x. Yeah, now that's 2. Number 4, find the derivative of 1 sec x over sine x plus cos x. 2 sec x over 1 plus sec x. And 3, 1 minus tan x over 1 plus tan x. Now, if you have the soft copy of the bond day, if you go therein, you will see answers to these problems at the back, so you can work your way to it. I have no problem with that. What I want you to do, what I want of you is to be able to find solutions to this problem. So today is 21/04/2024. So I'm signing out. Thank you very much for your attention.